So now that we've talked a bit about the thread pool mechanisms that are available in Java, let's begin to dive deeper into the key interfaces that are part of the Java Executor framework. And you'll see that there's a handful of them. So here's kind of a high-level view of the key interfaces. There's a bunch of other interfaces that are used sort of underneath the radar screen, if you will, in order to be able to implement the various components and mechanisms that comprise the Executor framework. But these are the good ones to start out with to have a good idea of. So the first one, and the simplest one by far, is the Executor Interface. And this simply provides a means of submitting new runnable tasks for execution. And as you can see, the interface for Executor is really, really simple. In fact, it's about as complicated as the interface for a runnable. And in fact, it takes a runnable as its one and only parameter. So you can see here that Executor is an interface. It has a method called execute that takes a runnable. And this is what's called a functional interface in modern Java terminology, because it's got a single abstract method, and that is the only thing that it has. So it's super simple. And what that execute method does is it arranges to execute the runnable. But how it does it, of course, depends on the implementation that's going to be provided. And we'll talk a lot more about that. So there's lots of different ways to implement that execute method. That turns out, however, the Executor interface turns out to not really be very useful in practice. You need more stuff usually. Not always, but usually. So because of that, there's another interface called the Executor Service. And the Executor Service extends the Executor interface, so it has the execute method, but then it adds a whole boatload of other methods, a bunch of factory methods that create and run tasks, as well as other methods that manage tasks and or the life cycle of tasks and or the life cycle of the Executor Service implementation itself. So you can see here, if you look at the slide, there's a bunch more methods. There's even more than I show here, but these are some of the key ones. So we have ways of being able to submit various types of tasks. And unlike the Executor interface, which is only used to submit so-called one-way tasks, a runnable is a one-way task because it has no return value. The Executor Service actually can support two-way tasks. So you can see these things known as callables. And they not only can be used to run a computation, they can also be used to get the results back. And we'll talk about how that works later. The way it works is by something called a future, which we'll talk about later. That's another interface that's important to understand to make sense out of the overall Executor framework, although it's not quite as important as the four interfaces we're talking about here. There are other methods here. For example, there are methods that you can use to shut down an Executor Service, either gracefully or abruptly. There are ways to check to see if the Executor Service has been shut down. You can check to see if the Executor Service implementation is terminated, which is different from having been shut down. We'll explain that later. You can wait for an Executor Service to terminate. And then there's also a bunch of methods that you can use for various gang scheduling tasks, like invoke all or invoke any, where you can have a bunch of things run and you wait for them all to finish, or you can invoke a bunch of tasks and wait for the first one to finish, and so on and so forth. So there's a lot of very powerful capabilities that are provided with the Java Executor Service interface. Now, the main thing to remember about Executor and Executor Service is they just run computations, and those computations are, either one-shot computations that are one-way, or they're one-shot computations that are two-way. But we don't think about any of these computations for Executor or Executor Service having anything to do with time. And that's because there's another interface called the ScheduledExecutorService that takes time into account. And you can do a bunch of different things with the ScheduledExecutorService. First of all, the ScheduledExecutorService extends the Executor Service interface. So it has all the same methods we just looked at. And then it adds several more. And these several other methods can be used to schedule one-way or two-way computations to run in the future. You can say, please run this task in 5 seconds, or please run this task in 20 milliseconds. So those are one way you can schedule things to run based on the passage of time. And those are what we call one-shot tasks that are run based on time. There's also ways of being able to schedule tasks that run periodically. So you can say, I want this task to run every 5 minutes, or I want this task to run every 30 milliseconds. And those are called periodic tasks. And there's a couple different variants with the periodic tasks. There's something called schedule at fixed rate, and there's something called schedule with fixed delay. And we'll talk about the difference between fixed rate and fixed delay in just a bit. So these are all ways of being able to do things that are based on time. And there are lots of things in life that are required to do time. A simple example that I'm sure you all use to make sure that you don't miss meetings or classes is the alarm app on your smartphone, where you can say, please tell me at 10 o'clock that I should get done with this silly class and go to my next class. So that would be an example of scheduling a task or a notification that will go off at that time. Other examples of these kinds of things, of course, would be stopwatches or countdown timers, where you say every minute, every second, I want to know so I can update my user interface to count down or to stop or move or whatever. So those are examples of time-based tasks, and we'll take a look at some of those in more detail later. The fourth key interface in the Executor Service is something that's called the Executor Completion Service. And this is by far the most interesting of the mid-school Java concurrency mechanisms. And what it does, it's a little hard to explain, but once you understand it, it's really cool. It decouples task invocation from the asynchronous processing of tasks and the asynchronous results that come back when those tasks are done. So the completion service is typically used for two-way tasks. That is a task that is meant to do something and then return a result, except that the way that we do it is we give back the result at some point later when the computation is finished. And a simple example that might or might not help to make this more intuitive to you is dropping off your suits or your clothes or your dresses or whatever you drop off at a dry cleaner, and then basically getting a little claim check. If you drop your clothes off at the dry cleaner, they'll give you a little piece of paper that says you can pick your clothes up 2 days from now at 5 o'clock or whatever. And then you come back later and you can get or take your clothes when they're finished. And so that's kind of the way that the completion service works. You say, here, do this work. I'm not going to wait around for it, but at some point I'm going to come back and I want to get the result. And this can be used to implement some really cool asynchronous processing patterns like the proactor pattern, which we'll talk about later, and is probably the most sophisticated and cool, and in some ways the easiest to use of these different concurrency mechanisms that are part of the Java Executor framework. Now, in this course, you'll get a chance to play around with Executor Service, and you'll also get a chance to play around with the Completion Service in different assignments. So that's the end of the overview of the Java Executor Service framework's key interfaces. Be aware that there's actually lots more interfaces that are there too, like future and runnable future and queued future and so on and so forth. But these are things that are a bit more in the weeds of the implementation and the programming. So we'll cover them when we get to that part of the lessons.